let us discuss motion in a straight line. Motion is common to everything in the universe. We walk, run, and even when we are sleeping, air moves into and out of our lungs. Automobiles and planes carry people from one place to other. Earth rotates about its own axis and also goes around the sun. Motion is change in position of an object with time. In this session, we shall learn how to describe motion of a body, motion of a point objects along one dimension or straight line. For this, we develop the concepts of displacement, velocity and acceleration. We know that motion is a change in position of an object with the time. So let us try to understand what is position first. In order to specify position, we need to use a reference frame. So let us define what is position. So let us define what is position. To define position, we need to use reference frame. So to describe motion along a straight line, we can choose an axis, say x-axis, as a reference frame. If I take x-axis like this, so this x-axis can be used as a reference frame. If I say this is the origin, and this is 1, and this is 2, and this is 3, 4. If as you go from 0 in this direction, you can take it as positive. If you go from here in this direction, you take it as negative. So here -1, -2, -3 and so on. Even you can have here 5, and here it's -4 and -5. So to describe motion of a body along a straight line, we can use this x-axis as a reference frame. So now this is called reference point. So whenever you say position of a body, then position of the body is measured from here, from the reference frame. For example, if you find position of the body, if you find body somewhere here, let us say if you find body from here, then with respect to this frame, you can say the location of the body is, or position of the body is, let us say x1 equals to 3. So you can also take its units. Maybe each grid is here 1 meter. If you say it's meter, then you can write it as 3 meter. 3 meter is the location of the body with respect to the reference frame. If you find body somewhere here, then you can write down location of the body or position of the body with respect to this frame as -2 centimeter. So now position of the body can be positive or negative. So simply position of the body is simply a distance of the body from the reference frame, from the reference, and here this body is located at 3 and this is your reference. So the distance from reference to that body is 3 meter, and for this case distance from the reference frame to the body is -2 centimeter. Now let us define what is path length and what is displacement. Let us define. So we already know that motion is a change in position. So if body goes from here to here, it may go from here to there and here to there, and whenever location of the body or position of the body is changing, we say the body is in motion. If location of the body is not changing with respect to reference frame, then we say the body is at rest. If location of the body or position of the body is not changing with the time, then we say the body is at rest. If location of the body is changing with the time, then we say the body is in motion. Now let us define what is path length and what is displacement. First let us define path length. Path length, and path length is defined as distance covered by the body in given interval of time. And similarly, let us take one more definition, that is displacement. Let us write here. This is path length is defined as distance covered by the body in a given time. Let us say that you can write down as say S. Now one more parameter, that is displacement. So displacement is defined as a change in position of the body. So you can write down displacement as delta x, that can be x2 minus x1. Here x2 is final position and x1 is initial position. So delta x is change in position of your body. Let us try to understand path length and displacement by taking some examples. Now assume that one object is moving from reference frame to somewhere here. Let us say in given time t. In this case, let us say that point, let us take it as P. This is, let's say, O. An object is moving from O to P. If object is moving from O to P, let us write down here path length, say S, or let us write here S. And now I will also write down here displacement. Displacement is delta x, and I am writing here. So now if body is going from reference frame to this point, let's say body is going from O to P. So when body is going from O to P, this is the path O to P. In this case, the distance covered by the body is 3 meter. That is what path length is. Path length is 3 meter. Whereas displacement is, it's defined as change in position. Then initially it was here and finally it is here. Then change in position is x2 minus x1. So x2 is finally it is here. Initially it was here. Then 3 minus 0 is also 3. So in this case, displacement and distance, let us write distance here. Distance and displacement both are same for this path. And you take one more path. Object is going from reference frame to this point. Let us say that is Q. In some time, let's say T. Then during this path, OQ, then distance covered by the body is 1 and 2 meter. Whereas displacement is change in position, that is final position minus initial position. Final position is minus 2, minus initial position, that is 0, minus 2 minus 0 is minus 2. So this is meter. So let us take one more path. Object is going from O to P and P to, let us say, R. So now the path is OP R. So it's going from O to P and P to R. Immediately it is returning. So in this case, the total distance covered by the body is, it's going from O to P, that distance is 3, and it's coming from P to R, that distance is again 1, because each grid here, size of each grid is 1 meter. From O to P it is 3, from P to R it is 1, so total is, it's 4 meter. Whereas change in position is, final position is here, that is 2, and initial position is 0, then 2 minus 0 is 2. So from here you can give some conclusions. The conclusion one is, path length can be equals to displacement in certain cases, and can be equals to, path length can be equals to displacement, and Path length can be greater than displacement. That is one more conclusion. And third conclusion, path length is only positive number, whereas displacement can be negative or positive. Displacement can be negative or positive, whereas path length is only a positive number. Because path length is defined as it's a total length covered by the body, whereas displacement is defined as change in position of the body. And now, even from here also, from general equation you can understand that as we define delta x equals to x2 minus x1, if x2 is greater than x1, that implies delta x equals to positive. If x2 is less than x1, then your delta x becomes negative. If there is no change in position, if x2 equals to x1, it means, x2 equals to x1, it means there is no change in position. In that case, displacement will be 0. So let us look at one more parameter. So now we said that displacement is delta x, and in this example we have also discussed if body is going from O to P, I said the distance is 3, that is path length, and displacement is 3. And the body can move from O to P in 1 second, maybe in 2 seconds, maybe in 3 seconds, or maybe in 10 seconds. So to define that, the rate at which the body is covering this distance, we are defining one more parameter, that is called velocity. First let us define what is average velocity. Average velocity and average speed also. Let us define. So average velocity and average speed. Average velocity is defined as the change in position or displacement divided by time interval. So mathematically, V average equals to change in position, that is delta x, by time interval, and that equals to xf or x2 minus x1 by t2 minus t1. If x2 is greater than x1, as I said here, then V average becomes positive. So V can be positive or negative or even 0. So if x2 is greater than x1, you get positive. If x2 is less than x1, you get negative. And the units for average velocity is x2 minus x1. x1 and x2 both are measured in terms of meter. Then t2 minus t1. t1 and t2 both are measured in terms of seconds. Then units are meter per second. These are the units. And similarly, you can define average speed. Average speed is defined as the total path length traveled by the body divided by total time interval. So then average speed, you can write down average speed as c, that equals to c average equals to total path length by time interval. So this will be only a positive number. C can be only positive because time is measured from 0. So time cannot be a negative, and time interval cannot be a negative here and here. But delta x, that can be a negative. So delta t cannot be negative. it's a positive, and delta x can be negative or positive. Because of that reason, you get V average, negative and positive also. But for this case, for speed, time interval is positive and total path length is also positive, then your average speed must be a positive number. And units for this one also, if you see, total path length, that is measured in terms of meter, you can see here, total path length, that is also measured in meters, and time interval is measured in terms of seconds. So unit for this one is also same as this. For this one and for that one, units are same. So let us define one more important parameter, that is called instantaneous velocity and speed. This is instantaneous velocity and speed. The velocity, instantaneous velocity, is defined as velocity of the body at particular instant of time, at particular time, and it is defined as the time limit of the average velocity as time interval becomes infinitesimally small. So instantaneous velocity is also like an average velocity, like V equals to delta x by delta t, but there is a limitation here, and this is the average velocity of the body, and as delta t tends to 0, you get instantaneous velocity. So now instantaneous velocity, let's say this is average velocity, then instantaneous velocity is defined as delta x by delta t, but there is a limitation, that is delta t must tend to 0. Whenever delta t tends to 0, the time interval will be very small. When time interval is very small, then you will get instantaneous velocity. You will get instantaneous velocity, and in the language of calculus, the same thing can be written as dx by dt. So this is rate of change of position with respect to time. This is rate of change of position with respect to time. And instantaneous speed is simply a magnitude of this velocity. So for example, velocity of particle A is, let us say, 25 meter per second, and velocity of particle B is, say, it's minus 25 meter per second. So if velocity of A is 25 meter per second and velocity of B is minus 25 meter per second, both have an associated speed 25 meter per second. In the both case, speed is same, because magnitude of velocity here is 25 and magnitude of velocity here is also 25, then speed is 25. So instantaneous speed is defined as magnitude of instantaneous velocity. So similarly, as I said, V can be negative or positive, and from here V can be negative or positive, and if V is not changing with the time, then we say, if velocity of any body is not changing with the time, then we say the body is moving with a uniform velocity. Sometimes velocity of the body may change. When velocity of the body is changing, then there exists delta V. So if there exists delta V, from there you can define acceleration. So let us define what is acceleration. So now let us define average acceleration. First let us define average acceleration. So average acceleration is defined as the change in velocity divided by time interval. So you can write average velocity as change in velocity by time interval. And the units for this one you can write, already we wrote for velocity it is meter per second, then you can write down units as meter per second, and for t once again a second, so that implies meter per second square is an unit for acceleration. And this is the average acceleration. You can also define instantaneous acceleration as as the instantaneous acceleration is defined as acceleration of the particle at any instant, and that is defined as the limit of average acceleration as time interval becomes infinitesimally small. So this is also like delta v by delta t, but instantaneous acceleration you get when you have a limit that tends to 0. So if the body is moving with a uniform acceleration, it means if acceleration of the body is constant with the time, then we say the body is moving with a uniform acceleration, and we will be dealing with the uniformly accelerated body here. So we will be dealing with uniformly accelerated bodies. We don't take non-uniform accelerated bodies, and we will be dealing with uniformly accelerated bodies. In case of uniform acceleration, your instantaneous and average accelerations will be same. So when instantaneous and average accelerations are same, you can write down A equals to delta v by delta t. So you can also write down this as in the language of calculus, you can write down limit delta t tends to 0 delta v by delta t as dv by dt. And I'm taking uniformly accelerated bodies. In that case, average and instantaneous both will be same, and then A will be equals to delta v by delta t. Let us consider a body that is moving with uniform acceleration A, and its initial velocity is u, and it means at time t is 0, velocity is u. As time goes on, velocity of the particle is changing. When time t becomes time, then velocity is v. So for this case, you can write acceleration as delta v, that is change in velocity. Change in velocity is v2 minus v1. You can also write here v2 minus v1 by t2 minus t1. Then v2 minus v1. So this is your final. That is at time t is t, velocity is v. And v1 is when time t is 0, v1 is u by t2 is t and t1 is 0, then you get t2 minus t1 is t. So this implies v minus u equals to at, that equals to v equals to u plus at. So this is final velocity of the body after time t, if the body is moving with a uniform acceleration A, and the body is starting with velocity u, and this is the equation. So here v is final velocity of the body, or velocity of the body at time t is t if it is moving with acceleration A, and this is your initial velocity of the body. And let us write down units for this acceleration. So we have defined A is delta v by delta t, and we have already defined, we have already given units. Now you take this part. So A equals to delta v by delta t, and here delta v equals to v2 minus v1. If v2 is greater than v1, that implies delta v will be positive. If V2 less than V2, V1, that implies delta V is negative. So it means for this case acceleration can be positive, and for this case acceleration can be negative, and if there is no change in V, acceleration can be even 0. If V2 equals to V1, delta V will be 0. When delta V is 0, then acceleration will be 0. If V2 equals to V1, delta V will be 0, then A will be 0. So A can be negative or positive or even 0. So when you get a 0 acceleration, it means that there is no change in velocity of the body. So it means we say the body is moving with uniform velocity. If acceleration is positive, then we say the body is having positive acceleration. If body is moving with negative acceleration, we say that negative acceleration is also called deceleration or retardation, and positive acceleration is called acceleration, positive acceleration. If body is having 0 acceleration, then we say the body is moving with a uniform velocity, and negative acceleration is called retardation or deceleration. So let us consider one example here. The velocity of the body is increased from 2 meter per second to 10 meter per second in let us say in 10 seconds. So what is the acceleration of the body? Now the question is, velocity of the body is increasing from 2 meter to 10 meter in 10 seconds. Then you need to find what is acceleration. So by definition, acceleration equals to change in velocity by the time interval. That change in velocity is final velocity minus initial velocity. Here initially the body is moving with 2 meter per second, and it is going from 2 meter per second to 10 meter per second. So final velocity is this, and initial velocity is 2. By that happened in time 10 seconds. 10 seconds. So that equals to 10 minus 2 is 8 by 10. That is 0.8 meter per second square. This is the acceleration of the body. So look at next problem. That is, a train started at 7 a.m. and reached destination at 9 a.m. Say a train started at 7 a.m. Let's say at point A, and it reached destination B, destination point B, at let us say 9 a.m. and the distance between A and B is 85 kilometers, let us say 85 kilometers. Now we need to find average velocity of the train between 7 and 9 a.m. So now the question is here, train is moving from point A to B, and it is started at point A. It is started at 7 a.m. at point A and reached point B at time 9 a.m. So the time gap here, the time delay or time difference, or the time taken by the train to come from A to B is, you can take here t is 0 and here t equals to, then here it is starting, if this is the reference, then from here to there, from 7 to 9, it is 2 hours. It's 2 hours. So then time difference is 2 hours, or t1 minus t2 is 2 hours. Then the distance is 85, or the change in position is 85. So average velocity is defined as delta x by delta t, and the change in position is initially it is here, you can take this is the reference point. If this is the reference point, then final position is this and initial position is that. So B minus A is 85 kilometer by time is the time difference is 2 hours. So that will be equals to so average velocity equals to, so it is 85 by 2 is 42.5 kilometer per hour. So velocity can also be measured in terms of kilometer per hour. Let us see 1 kilometer per hour equals to how many meters per second. So 1 kilometer per hour equals to 1 kilometer per hour equals to 1 kilometer per hour. So let's say 1 kilometer per 1 hour. That equals to 1 kilometer means 1000 meters by 1 hour means 60 minutes. 1 hour means 60 minutes and 1 minute is 60 seconds. So it means 1 hour equals to 60 into 60 seconds. So it is 60 into 60 seconds. You can cancel 2 zeros. Once you cancel 2 zeros, you get 10 by 6 into 6, 36 meter per second. So that equals to, you can cancel once again, you can write it as 5 by 18 meter per second. So 1 kilometer per hour equals to 5 by 18 meter per second. So you can use this factor for conversion from kilometer per hour to meter per second.